Okay. So, all right. So I'm recording now, and you should be able to hear me. I apologize. I'm a little sick, so we're just waiting a little bit. I'm helping them set up everything. So the first thing you're gonna do is you're gonna go on your laptop. You're gonna go to this website link here, keycad.org. It'll take you straight here. You're gonna click on download. And then it's going to ask you what operating system you're on. I'm personally on a Windows device, so I'd click Windows. And then I believe you can pick any of these depending on your location. I did worldwide. Um, all of these end up being the same versions. They might be in different languages, but I usually just do the GitHub one. As soon as you click this, it's going to download it for you. So a window will pop up or it'll start downloading in your web browser. You can save this anywhere. Um, I have a KiCad projects folder I made specifically for my KiCad projects. I mean, I guess you don't need the executable. You can just put that in downloads, but and then I have other folders to help with organizing everything. So the first thing is you may be interested in importing 3D models that you find online to put on your circuit board so you can see what it would look like with all the components. It really helps to make sure that none of your components are overlapping with each other, that you can actually physically fit them on the board. Um, the imported libraries are really important. That's what's going to give us all our symbols and our footprints, which I'll talk about a little bit later. We'll get into symbols, but we're not going to talk too much about footprints until next Wednesday. And then I have a folder here for all my projects. So these are all the projects I have. Um, so we're going to be doing the IEEE badge and the IEEE dev kit with the ESP32. We're going to start out with the badge. It'll be easier and more simpler. And then we'll move on to the developer kit. You guys will really start to get a feel, like a flow for how to do it. It's really easy. But for this executable file, just throw it in your downloads and then run it, and it'll walk you through the steps of downloading KiCad. The other thing you're gonna need to download, that would be really useful. DigiKey is a company that sells electronic components. I can show you here. DigiKey Electronics. And this is one of the providers, very reliable, well known. You can search up components, so like capacitors, for example, and then you pick what type of device you need. So do you need ceramic capacitors, film capacitors, aluminum capacitors, and so on. So they're just a company that sells components. They're reliable and everything. They have a huge library of footprints to help kind of kickstart you because you're gonna have what KiCad offers for your footprints, and then you're also now gonna have what DigiKey has. Hello. Yep. I'm recording this too now. So I'm gonna upload this and then hopefully that can help students with everything too. Do you have a laptop? All right. So if you want to follow along, just go to keycad.org right here. And then you can start the downloading process. It's completely free. This is if you want to follow along. We're going to make two separate circuits. One's going to be like a badge you can actually wear. And it'll have LEDs that light up and you can write your name on it. And then the other one's going to be a developer kit you can actually use for other open source projects. Um, and if you miss any of that, I can go back and show you how to do it and everything if you have questions. But I also have the recording, which I'll upload for you guys later. Uh, I'm using both eyes right now. Like, um, so the other website you'll have to go to is this one on GitHub. I don't believe you'll need an account. Luke, did you need an account? Yeah. Yeah, mine's already logged in. So I'm not sure if you need an account or not. I don't think you'll need one. But this is the website link here, DigiKey/DigiKey KeyCAD library. And it's just gonna help jumpstart everything when you're looking for components to put on your board, the footprints and sometimes symbols. So once you go to this website, you're gonna click on code, click on download zip, and then I go to my KiCad folder, and then which I made it and I named it KiCad folder. That isn't automatically put in when you download KiCad. And then I have a imported library section, and then I break it up by components. So I have one that's DigiKey, and then I saved it here. So you'll save the zip file here and then unzip it here, and that will just help later on when we're picking our footprints and symbols to make the circuit. Yeah, it should be pretty straightforward. All default stuff. It should have everything you need selected automatically. Okay. Um, yeah, that's it. So just leave it there. Leave it there for now. And I'll show you guys how to import libraries into KiCad. You'll have to do it very often. Um, so I'll wait till your download finishes. Um, then you can open up KiCad. This is what it'll look like. It should download the newest version, I think 6.0, 6.0.7, I think they're on right now. That's what I'm using. If you'd like, you can use earlier versions of KiCad, but I think KiCad 6.0 is the best to work with right now. Yeah. They got a lot of cool stuff, and they're implementing Python as well. So there's a lot of plugins that use Python scripts to help make your life easier, and that's really helpful. Right. Yeah. Right, yeah. So you can I haven't messed around with it too much, but you can actually write the code and then like paste it into KiCad and it'll draw out the circuit for you. It's super awesome. I don't know like the syntax or like all the different classes they use and stuff to accomplish that. Maybe I can implement that in the future, but for now I don't know much about it. Yep, yep, yeah, yeah. I think that's another reason I really like KiCad is because it's open source too. And so that's really helped implement a lot of useful features and stuff. There's still some things they need to work on, especially when it comes to like bill of materials and stuff. And having a couple of extra file formats available to you. But besides that, it's really good, I think. Yes, so Altium is usually what is used in industry. It's another big, huge software that costs thousands of dollars for the license, and then they distribute it to all the workers. Altium is, I think, the industry standard right now, and they have extra nice features about um, like it'll automatically give you the footprints for the components that you're picking out for your board, which is really nice. Whereas in KiCad, we'll have to manually look for the components, figure out its package type, and then find the footprint for that device manually. So, and I'll show you guys how to do all that, but that's one of the perks of the licensed software Altium. It does it for you. And you'll learn about a ton of different manufacturers. I actually really recommend in my favorite section here. I have one for like electrical components. So all these different manufacturers sell components. All these different places here. I kind of have it mixed up. Some are for footprints, some are for printing out PCB, like PCB way, and JLC PCB is another one. That's this website here. And they all use Gerber files to take in your PCB design. And even the milling machine uses Gerber files. It's a standard for all PCB design, is these Gerber files. And I'll show you guys how to generate those files when we finish our design and everything. Is your KiCad still downloading? Okay. We got plenty of time. I'm gonna wait until his finishes and then I'll walk you guys through making a project and like the way I'm organizing everything in my files. It'll be on mypnwlife.pnw.edu. I can maybe throw that in the chat. mypnwlife.pnw.edu. That's the website, and that should be on video too, so you can watch me type it. uh, but that website is where I'm posting everything, all the materials for the Python sessions we have, all the PCB design sessions. I think I'll post them here. Uh, wait, which app are you? Are you talking like the that campus groups app? It's similar, but like it's useful for using like events and everything, but I don't think, let me pull it up. I'm not sure if you could see like files and stuff. Oh, you can. Documents is what it would be. And then have it in workshops. PCB. So here, let me show you. For any of you that are on your computers, you'll go to this website, mypnwlife.pnw.edu. It'll look a little bit different for you guys. Since I'm the president, I have a different view of everything. So you go here and then you can click on files here. You guys should all have this side tab here. You'll click on files and then go to IEEE workshops, and then it'll be in the PCB workshop. The only thing that's in here right now, I believe, is my PowerPoint that I presented last week, which was just like some of the vocabulary. You guys are going to learn about solder mask. You're going to learn about solder paste. You're going to learn about like how it keeps track of like all the different layers. We'll get there eventually. I don't want to rush it too much, but I'm going to try and take it really slow, just so we can kind of like ease into it and understand like the layout of everything for KiCad. But overall, once you got it down, it's a pretty easy like flow. There's a general workflow no matter what design you have. Okay, so I went over this and this. What are we at for the download? 2 minutes. All right. Hey, no worries. I'm recording it. So hopefully that'll help if anybody wants to review this and catch up. But we're currently just downloading the software. So do you have a laptop? Yep. So just go ahead, go to kicad.org, And I already went over like the whole thing, but you can go to this website. It's pretty straightforward. Just click on download, and it's about 6 GB. So I don't know. Hopefully you have enough space. Okay. Okay, got it. I'm expecting a lot of people to just kind of like slowly come in. I was gonna do like a 1 to 2 p.m. session and then end it and then do a 2 to 3 p.m. session for other students that can make the 1 to 2 p.m. Um, I'm still trying to think about how I'm gonna work that out. And I don't know if I should maybe make like separate recordings for the two then too. I might just record it all if my computer can handle it. Yeah. Mhm. So just let me know once you have a KeyCAD opened up. Oh, okay. Um, if you want, I can unplug one of the outlets here if you want to move over, maybe. Yeah. All right, like I said, this is all recorded. Maybe I can come back and help you. All right. Yeah, just try to keep track of all the steps. So when you open up KiCad, this is what the 6.0 version looks like. Um, there's a bunch of different tabs here. So the first thing you're always going to start out is with the schematic editor. And that's where you're going to build your actual schematic. It looks a lot like PSpice or Multisim when you put together your components, and it uses all the traditional symbols we're used to. Um, each component we in KiCad it's called a symbol. So I'm gonna refer it from that point on. Sometimes you'll have to make your own symbol, and so you would use the symbol editor here to create a custom component. Generally, you can either make it like a square shape, just for like a if you're doing like a chip or an IC, or if you want, you can make it look like exactly like the component. So if it's a chip that usually uses like a QFP package, which is it's kind of like square shaped with a slice on the one of the corners. You can make the symbol look just like that, and then there's kind of two methods for organizing the pins. You can either have all the input pins on the left and all the output pins on the right, or you can order the pins exactly how the chip will actually have it. The way you order it and the symbol doesn't matter because KiCad um, will handle everything for the footprint you associate to it and put each pin where it should be for the actual component. So so the symbol usually it looks nothing like what the actual board would look like. It's just to visually see all the connections. And then when you actually go to the PCB editor here and you start laying out all your components, that's when KiCad will be like, oh, okay, here's all the footprints you assigned to your components. This is what they look like. And now it's up to you to arrange it how you want it and then make all the traces and everything. Sometimes you need to make specific footprints for your components, which are the actual outlines of the chip or the component. Sometimes for like resistors, it'll just be a square shape, like the general size it should be, and then where it should connect. There's two types of connections for PCBs. There's through hole or pads. which is also usually known as like surface mount technology or surface mount device. So that's SMT or SMD. They're the same thing. Um, so the two methods are you can either have a layer of circular copper and then a hole drilled through, and then you can take the resistor components that you're mostly used to for like breadboards, and you can put them through the holes, and then you can solder them to the board, and then you cut the remaining uh, leads off. The other method is you can have a component that kind of just has like a pad or a layer of copper on it, and you just match it over the layer of copper on the board and then solder that. You probably wouldn't want to use a traditional well, there's a lot of ways to solder it on if you're doing it like manually by hand. I've seen a lot of methods. My favorite is by using soldering paste, but you do have to be careful because depending on the distance from each of the pins, you can't have any of them bridged to the other, or else it's not going to work. That distance between all chips, that's usually known as pitch. Um, and it's common practice when you're naming like your footprints to tell in the name of the footprint the size of the chip, the pitch between the pins, because when you're picking out your components and you're looking at their data sheets, they'll tell you the package type, usually, ideally. If they don't tell you the package type and you have to make your own footprint, you'll have to go all the way down to the bottom of the data sheet and see like it'll have all those parameters like here's the distance between the pins, here's the length, here's the height, here's the width, and that whole ordeal. I can actually maybe I can show some of that off in my senior design. So let's take this chip for example. So this is a data sheet for a device called a TPS 5430. It's a buck converter. And it gives some details about like the functionality of the component, but this is the part you're going to care about. The part number I wanted was a TPS 5430, and it has a package of HSOP. That package that I refer to, that's what we want for the footprint. So the footprint you're going to look for this component is a HSOP package, which I believe stands for heat sink shrink. I forget what the OP stands for, but there's tons of them. There's tons of them. So you'll see a ton of these different packages, and you'll kind of pick up what they are over time, like what they look like. If you didn't have that, then you would have to go all the way to, it's usually at the bottom of the data sheet, right, right down here. Sometimes you'll have stuff like this, like it'll give you a recommended layout, and sometimes that can help you. But that's usually in the better quality data sheets. If you look at a lot of like some of the cheap components, they don't give you that usually, which sucks. This is what you'd be looking for here. So if you have to make your own footprint, you need to look at the dimensions it gives you. So this is the size of the chip, the height. This is the length from pin to pin. This is the length of the actual body of the chip. Here's the distance between the pins from the center of the pin to the other center. So that would be your pitch from pin to pin. And you would have to do this all manually. You'd have to add the exposed pad. So ideally, you would find the component. If you didn't have the footprint, you would Google it and see if somebody's already made the footprint, download it, import it to KiCad, and then repeat that for all your components. For integrated circuits or chips, they usually have like that general package. For like resistors and capacitors, you'll have to find them yourself. Um, so I saw you just walk in. If you want to download KiCad, do you have a laptop? No? Okay, so unfortunately you won't be able to follow with us. I'm recording these though, so you'll be able to, if you have like a personal computer, like a tower at home, maybe you can do this. And I went through everything on what to download ahead of time already. So the first thing you're going to do is you're going to click on File. While you have KiCad open, you're going to click on New Project. I named it IEEE badge KiCad or IEEE badge. That's the first thing we're going to make. Because it's a little bit easier. If you find out like PCB design's not your thing, I figured if I started simpler, then it would be something small enough for you to stay interested. And then we'll move on to the developer kit afterwards. You can create this anywhere. I recommend making a folder for like all your KiCad projects. So you can right click, go to new, and you can create a folder if you'd like. So I'm going to open that project because I've already created it. You're not going to see these yet. It'll just be IEEE badge.KiCad Pro. Just a couple things before we move on. So I made this folder KiCad projects. That's where I'm going to put all my KiCad related stuff. In retrospect, I probably would have just called it KiCad. In here, I have a folder for imported 3D models, imported libraries, and Python scripts, because a lot of the plugins are just Python scripts. So it's good to keep them separated so that when you move on to the next version of KiCad and it deletes everything you had, you'll still have all the libraries you found and all the 3D models you found over the years, because you kept them as separate folders. The only thing is that when you move on to the next version, you'll have to import them all again. And then in here, I have a folder for all my projects. So I have the IEEE badge project in here, the dev kit, and a couple of other things. The voltage regulator, that's the first PCB design I've ever made, and Spark Spin is my senior design. So that's how I recommend to organize it. You don't have to do it that way, or if you find some better way online, you can do it that way as well. That's perfectly fine. So the first thing we're going to mess around for today with is the schematic editor. So just click on the schematic editor and it should ask for like a name. Oh no, it'll just pop up. Okay. So yours will be blank. You won't see any of this. In fact, I'll just kind of move this out of the way for now. This is what you'll see. You won't even have any writing here. Usually the first thing you're gonna do is does everybody have that open? Were you able to open it? So there's going to be a pop-up for global library. Just pick the recommended one and then click OK. And let me know if what pops up. Yep. So then confirm. Yeah. Okay. So now you're on the same page I am. Hmm? What do you mean? I don't know. It's just the format, I guess, for your computer. You can probably change that and mess around with the settings. So usually the first thing you want to do is I believe it's this one. Yeah. So you're gonna click on the page settings right here, settings for paper size and title block info. And you're gonna want to usually put in the date. So this is when I started this way back, and then this is the current date. So instead of typing the date, you can just click these arrows and it'll put the current date in for you. You can put the revision, because usually you're going to go back and change it over and over and over. It's good to keep track of what version you're on. There's no really specific like format, like you can do V01, 0.1, 0.2, or 0.01. You can even do the alpha beta thing if you'd like with like software development. And then you give it a name and just what your device is going to do, or something that gives you an idea of what the board is for. And then who designed it? You want to get credit for your design, so you want to make sure that that is there as well. I know it says company, but you can really put it anywhere. It doesn't matter where. And then just click OK. So then that will all show up at the bottom of your page here. So designed by me, file IEEE badge. That's the project that it's currently in. Sheets has to do with, you can make different hierarchies. If you can't actually fit the whole PCB design on this sheet of paper, you can create like sub page sets that will have their own sheet, just like this one. And then you can make it so that that block will have inputs and outputs, and you can have kind of like a bunch of subsystems that connect to each other if you can't fit the whole schematic on a single page. It tells you your version and everything, the size of paper. If you wanted to print this out, you'd be able to, and that's the page size. So a really big thing with KiCad is keyboard shortcuts. So if you want a entire list of all the keypad shortcuts, you go to help and then list hotkeys, and then you can make it bigger with the square right there. And these are all the different hotkey shortcuts. There's tons of them. As we go through this, you don't have to know all of these. I'll kind of go through the most commonly used ones, or at least the ones that I personally use. And you'll just kind of get used to these over time. So the first thing you're going to want to do is usually start adding components. So on the right side here, you can see a bunch of different tools. Some of these are to add components, some of them to add the ground side. I guess I'll just go through each one. So this one right here is for adding a symbol. So symbols is what KiCad refers to for every single component that you'll ever have. So if you click on that, it has a bunch of different general components. You can add Boolean logic components. You can add chips that have already been designed or you can find online, amplifiers. Here's a custom imported switch I have. Connectors I imported, so you guys don't see those. So battery management, here's one that you guys should have. The way KiCad knows like what symbols you have is based on these libraries. So I guess I'll walk through that right after this. But in the KiCad library, some of these, this is all that comes by default. There's a few of these like you won't see this BS3 or B4B, B8B. Those are libraries I imported that I found online. And then these DigiKey ones, that's what DK stands for, is DigiKey. Excuse me. I'm going to show you guys how to import that right now. So if you go to Preferences and then go to Manage Symbol Libraries, this is where you'll see all those different component libraries that I just showed you guys with all the symbols. If you wanted to add your own library, you'd go all the way to the bottom here. And you're going to want to click this plus sign here. And then you'd give the library some type of name. So I'm going to name it test. And then once you named it, you need to tell KiCad where it's located. Where did you download this library? So you would click on the little folder symbol here, right on the right. And then you would look for, so I have it here in this imported libraries folder I made. Here's a bunch of components I've just collected over time. Here in the DigiKey folder, this DigiKey library master, this is from that GitHub repository that I showed you guys earlier. Hey everyone, just pick out a seat, sit down anywhere. Yeah, no worries, no worries. I'm recording everything right now too, so anything that you guys miss, I'll be able to post it online. You'll be able to see everything I've talked about. Okay. So here's the DigiKey library from the GitHub repository. It's just a whole bunch of extra symbols and footprints to help you guys kind of like kickstart everything. In case you missed it, this is the website right here from github.com/digikey/digikey KiCad library. To download this library, you're going to click on code and then download zip file. And then I put it in documents here, KiCad projects, imported libraries, and then I made one for DigiKey, and then I saved it here. And then you just unzip the folder into the same area. So in order to import that into KiCad, you would click here on the file. You'd go to where you saved the library, DigiKey, here, and then we're importing symbols in this case on the schematics. EE schema is what KiCad calls it, the file type for the schematic. You're going to want to go to DigiKey symbols, and then you want to select all these .lib files, which are library files. You don't want these .kicad sim files. So instead of selecting these each individually, I find it a lot easier to just filter this and then click on the .lib, and it'll show you only the .lib files. And so you can scroll all the way down and what? Can't shift click. Okay, so that's for adding. Okay, I think I know what the problem is. That's for adding a individual library. There's a way to add these in bulk. If you ever like if you made a mistake or selected the wrong thing, you can click on this test one and just delete it, and then it'll remove it for you. To add it? Yeah, I know, but there's an easier way. Instead of adding the plus, that's for adding like a single type of library. If you actually click on the add existing library here, add in the folder, I believe this is how you do it. Imported libraries, DigiKey, symbols. Yeah, here you go. So now if you click the top one and then scroll all the way to the bottom, because you don't want to click all these individually and add them individually. That's going to take forever. Just select the top one, scroll all the way to the bottom, and then if you hold shift and then click the bottom file, you didn't do it. It should select all of them for you. There. Yeah, I don't know why I didn't do it the first time. So go all the way to the top, just select the top one, scroll all the way to the bottom, hold the shift button, and then click, and it'll select all the .lib files for you. And then you would click open. Now, I'm not going to do that because I already imported all of them, but you guys will click open right here. And you'll then see all these different DigiKey symbols populate here. Does anybody have problems with that? Did you, or are you got go? Okay. Were you able to do it? The symbol libraries, or it was a separate thing. You'll have to download. So you'll have to go to this website here, github.com/digikey, and then you'll click on code here, and then download zip. And then I downloaded that zip file into my KiCad projects, imported libraries, and then I made a file for DigiKey because you're going to collect components over the years, depending if you want to do this as a career or not. They're just useful to have in general. You never know when a component's going to pop up in another design. So I named this one DigiKey, and then you can save it here. This is what they called that zip file that you would download from that website. If you actually just Google DigiKey KiCad library, it should pop up. It's right here, KiCad library DigiKey. That'll take you to the DigiKey website, and then it'll say our library is available on GitHub. And click Get It Now, and this should take you straight to the GitHub website here, and then code downloads it. And so this is a common process you want to go through because you don't want to manually make the symbols if you don't have to, because it takes a lot of time. You could make a mistake. There's a bunch of things that could go wrong. With the symbol, it's a little bit easier, but for the footprint, you definitely want to try and find the footprint online. Most of them are made if it's a common component, but very rarely you should have to create one manually. We'll get to that next Wednesday. I'll talk all about the PCB layout and all the tools and stuff for KiCad. And then, of course, if any of you guys have a laptop, feel free to join in and follow through. If you have any questions, just let me know. Were you able to find the website? Okay. So then once you download that, it's a zip folder, so you'll have to unzip it. Usually just unzip it in the same place. And then you'll go to, again, for the libraries, to add those, you'll go to Preferences, Manage Libraries. And then you'll see all your libraries here. I can't remember if it gives you a pop-up, but there is a difference. So if you look here, there's global libraries and then there's project-specific libraries. So you can import libraries as either global or project-specific. The way I showed you guys was in global because these are general components that will help you with any design. So global means you'll see it on any of your projects that you make, separate from this one. But you can also, if you only wanted the components to show up for one project that you're working on, you can put it in the project specific libraries instead. And that's the same process. You would just click here. You'd go to wherever you saved the libraries. You'd go to imported libraries, DigiKey, symbols, and then I like to filter it so it's only the .lib files because that's all you need. And then just select all of them and then open. You would click open. Then they would all pop up right here. But I think it'll benefit you if you put it in the global libraries because it's a lot of components that could help you. So after that, you can then on the right side of the KiCad here, you can either click add a symbol every time you want to add it, or you see it shows the letter A right next to it there. You can also click A on your keyboard and it will automatically pull this up for you. So like I said, KiCad's all about shortcuts, keyboard shortcuts. Try and memorize them. That's the first one. Click A to add component. Most of them are pretty straightforward to memorize like that. A for add, but sometimes they're not straightforward like that. So some of these are the KiCad already implemented libraries. But if you scroll down right here, DK, so these are all the libraries we add. So they're just extra components. So here's alarms and buzzers. So here's the symbols made for them already. Here's some automotive relays. I'm not sure what these are. Balance, maybe? I don't know. Jacks and plugs for connectors. It all depends on what you're designing, right? So I'm gonna go over a couple of the other features you have here. So if you click on power ports, this is where you find all your voltages. You gotta pick out the specific voltages. And they also, so they have some general ones, negative VDC or VDC or BAT, Earth, that's your ground, AC. It doesn't really matter which one of these you pick. KiCad is not gonna make sure that your board doesn't get ruined based on like too much current or too high of a voltage. You have to do that yourself. So you have to keep that in mind. You'd probably run it through like Multisim or LT-Spice beforehand to make sure you're not gonna have too much current on one of the lines. That's up to you to find out as a designer. And then you have to make sure your copper tracks are wide enough so that it doesn't blow. As far as which earth or which ground you pick, it doesn't really matter. Earth usually literally implies that your device is connected directly to the earth ground. Kind of like, I don't know if any of you know, your houses, your homes usually have a ground rod that's physically put into the ground to ground your house, all the electronics in your house. So that would be considered a earth ground. For general purpose though, I would just use ground. Sometimes it's important to separate your ground so you can number them like this, but for anything we make, it's not really important unless you're in like telecommunications or if you have special signals going around your board. You can also separate your grounds, analog and digital grounds, but that is very, very, very uncommon. Usually you want to just keep it all as one ground. There's one more. I don't know why it's called ground power, but this symbol specifically usually refers to like a chassis ground. So if your container for your device is made of metal, you can attach your ground to that, usually by a screw or like a wire. And that is considered a chassis ground. And sometimes if you want to specify that, you can do that. So let's go ahead and just start adding components. So I would click A to add a component, and then you can type the component in the filter here so you don't have to find it. So R is for resistor. So you can click R, and then you can basically just pick a place to place it. You can then, if you want, you can duplicate it instead of continuously adding another component. You can either copy and paste it, or you can duplicate it. And then also keep in mind, it shows you all the keyboard shortcuts on the right side for any of these. So that can also help you. So for duplicate, it's Control D. So I'm just going to hover over the resistor, type Control D, and it'll duplicate it for me. And then I'll do it again and again and again. I think you need 4, 5, 6, 7. We need 9 resistors. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We're then gonna need a battery. So that's going to be here and power, which you can also, instead of clicking A, I don't know if you saw it, but you can click P for power. So I'll try it now. Click P, it'll pop up. And then we want a battery voltage. That is not what I wanted. Okay, symbol, battery. Okay, this is where I got it from. And then I wanted to use specifically DigiKeys. This one right here. So this is the one I wanted to use. So it looks like your traditional DC battery symbol. In this case, they named it BS7. I'm not sure why DigiKey would name it that, but this is in the D-key battery holders, clips, contacts library, which is what we just imported from DigiKey. We'll place that. It doesn't really matter if it's like an add symbol or a power symbol. You can use either one. It's really just for your reference, and so that KiCad knows what to connect to what when you get to the PCB design. So we need 2 capacitors. They're going to be electrolytic capacitors, so those are usually polarized. So these are called C polar. You can use whatever symbol you want. I'm going to use the US polarized capacitor symbol. In case if you missed that, maybe in one of your classes, this is how the US uses their capacitors to represent polarized capacitors. So the straight end is the positive side, and the curved end is connected to negative or ground, usually. Um, Another useful shortcut, when you select your component, you can click it again to drag it around, or instead you can click M for move, and then you can move it around that way. So M, because we're gonna have to reorganize everything here in a minute. Um, this component here, so I'm not sure, do you guys want me to walk you through how to create a symbol, or do you want to just stick to importing them from online? It's usually a lot quicker that way, but like, if you guys want to know how to do that, I could show you how to. Any preference? Any import? Okay. All right, then we'll skip that. So add. Yep. Yeah, and it'll show all your recently used components will slowly populate right here under recently used. So if you literally type C underscore polarized in the filter search bar, it should pop up. So you're also gonna need this. It's a 555 chip. It's okay if you don't get like if you find a different model 555 chip, might not be called 555 or in this case 7555. Um it might be called something else. Well, you know what? That one's not gonna show up. 555. No, it's not that one. I forgot. Yeah, that's in the created symbols. Um, BCC's discharge threshold Q. Yeah. Okay. This one should be okay. Any of these. They're in the timer library. Any of these should be okay. They're all pretty similar, just they have different model names. We might have to go back and change this later, and that's a very common thing you'll have to do. I'll show you guys how to do it. Are any of you guys unfamiliar with what a 555 timer does? You all know what a 555 timer is? So a 555 timer just essentially you provide it some voltage, and there's a very specific configuration for it to control how often it creates this pulse. But it basically creates a square wave pulse for you. So it's basically just on, off, a very consistent, even square wave. It's not pulse width modulated or anything. The off time is equal to the on time. Um, and essentially we're going to use this for on the PCB. It's going to make the LEDs glow. Basically, it's going to light up and then turn off, and then light up and then turn off. If you just had the 555 by itself, it would just turn on, turn off, turn on, turn off. It'd be kind of like blinking, basically. But we're going to use a well, let's go ahead and add it. We're going to use a NPN transistor. Actually, you know what? There's a very specific model, 2N3904. So if you type in 2N3904, there we go. That's your basic bipolar junction transistor, or BJT. It's an NPN transistor. This is what's going to give it that glowing effect when it turns on and off. Okay. So oh, there's one more component. EG1. If you can find the exact component in these libraries, that's ideal, because usually, in this case, it's a switch. The reason that's usually ideal is because if you click on the component and then double click it, in here, it'll automatically already have the correct footprint for that type of component assigned to it. But if you aren't going to use that specific component, or digit keys out of order on that component, you'll have to find a different one. And we'll probably run into that at some point here. So now we're going to start building the circuit. I already have it created. I was just I wanted to walk you guys through or adding all the symbols. This is what the circuit's gonna look like right here. The only difference is you guys will be using this chip instead. This is one I designed. If any of you guys want to maybe like on my own time or personal time, if you want to know how to create a symbol, just ask me and we'll schedule a time and I'll show you how. This is the one I created. You can see all the pins should be relatively the same. I called it VDD, they called it VCC, but you have TR, which is trigger, CV, which is the control voltage, ground, R is the reset, RST, Q is the output, I believe, and then discharge is discharge, and threshold, that's THR or thresh. You can actually even go into these libraries and go to edit symbol. And if you wanted, if you really wanted, you can change the names here. Thresh, and then save. You don't have to do all this. I'm just showing you guys. You can change it in the symbol there. So now it says threshold, just like mine that I created. So just go ahead, start wiring the circuit. I realized I didn't show you guys how to add wire. So that's this symbol right here. You can either click on this button or you can click W on your keyboard to start adding wire from wherever your mouse was currently at. So if I wanted to, oh, and if you want it to like stop, just click escape. If you ever like don't want to play something or you accidentally click, just click escape and it'll remove it like that. When you're actually wiring it, so let me go ahead and move some wires. And then I'll show you a cool fancy way to. So to actually add the wires, you'd come to the end, you'd actually connect it. You'd click where you want to start, click where you want to end. Or if you're already at the starting point, just click W and it will automatically place it. And then you just click at the end you want. Then this has to connect up here. And then another nice feature with KiCad, instead of connecting like here to here, and then in between the resistor and the LED, and then the end to here, you can actually just click here, draw a line all the way through the components, and it'll place it on both ends for you. So you don't have to click multiple times. It just saves a little bit more time. So just go ahead and start wiring this circuit here. If you want to move it, reposition it, you can drag and select the whole thing. Click M and you can move it or reposition it. Click, if you want to delete a component, just select it. Click the delete button on your computer, on the keyboard, and it'll delete the component you had selected. If you ever get like crazily like zoomed out or anything, and you can't find the page again, if you go to the top here, click zoom to fit, and it'll refix you on the page. And then if you want to zoom in on a specific thing, you can click on zoom to objects. Or you can also do zoom to selection. So I can select an area I want to zoom in on, and it'll zoom in for you. So I'll just let you guys wire the schematic and let me know when you guys are finished. Okay, so if you go to add, oh yeah, I did forget if you type in LED, yeah, here. Just click on the LED and then add it. And then these were actually originally named LEDs. So here you can look in the value. This value section is just for reference. So this is to help you or whoever's looking at this understand more what the schematic is doing. So this was a basic LED component, but then I wanted to specify I'm going to use blue LEDs for IEEE, you know. So I just went to the value here and I changed it to blue. and then I click on OK, and it'll change to blue. And now whoever's reading this knows, oh, it's a blue LED. And that can be important sometimes when you're picking components, because different color LEDs can have different forward voltages to turn on and turn off. So you could change this to red. You could change this to, or yeah, you can, instead of clicking on the symbol, you can also just click on the name here, double click, and that can pull up the value too. And I can change this to just about anything I want. So you can mess around with that if you want. Sure. What's up? Here? So those are just referring to the inputs and outputs for a basic 555 timer. If you actually look up, can I do this? There you go. So if you look up a 555 timer, go ahead and pick out any of the data sheets here. So this is a LM555 timer. It gives you some details about like what the inside of it looks like. Anything with like 555 in it, it's usually the same purpose. It's a timing circuit or used for timing circuits to keep track of like on and off pulse. I've used it for like a digital clock before. Every time it went up, the seconds part of the clock would increment. And so the timer clock just creates a infinite on and off pulse. That's like one application, but they're used for a huge variety of things. But they are the common inputs and outputs for every 555 timer. So there's a trigger input, ground, there's a output, there's a reset, threshold, control voltage or CV, discharge or dis or charge, or you can name it anything you want. Just whatever you think will help the user understand the best about what it's doing. And then VCC for power. So essentially what this thing is, it just has comparators and some flip-flops. And if you wire them up in a specific way, you might have learned in your digital system design class, or when you get there, you'll learn about it. But it's just wired in a certain way so that with this specific configuration here with the two resistors and this capacitor is going to charge up to the voltage that you're giving to the chip. And once it gets past a certain point that they're calling threshold, the comparator will flip because it will no longer be true that this voltage is higher than the other. And so that will change the flip-flop to a 0, and then the output turns down to 0. And then as the capacitor is discharging, it'll go low enough to a certain point where the comparator will switch again. The flip-flop will become a 1, and then you'll have your on signal. So this is just a specific common configuration for all 555 timer circuits. You'll learn about it in some of your classes. This part of the circuit here at the output is what's going to cause the glowing effect with the transistor here. And it's essentially just going to cut down the voltage and then rise up the voltage at a constant rate so that it gives the LEDs a glowing effect. All the resistors here are just so you don't have like an amp of current going through the LEDs, then your LED is going to blow. And the button here is so that when you're carrying the badge around, you can turn it off so the battery doesn't die as quickly at least. And then the battery here is for the power for the whole circuit. Let me see if I can find anything else. On the side here are just kind of like some visual things. If you don't like the gridded dots in the background, you can turn that off. Um, there's a couple of different units you can use here. So I think some of you weren't here last week, but there is an extra unit you need to be familiar with in PCB design and a few other things. I think it's used for like map designs, like physical maps too. But you have inches and millimeters, but then you have this unit called mils. Mils is not a millimeter. Mils is 1/1000th of an inch, and it's just another more accurate like distancing because sometimes in PCB design things are so small you want things as close as possible to the 1/1000th of an inch close or away from each other. Um, it's not really important unless you're like concerned with like having a component super close to something but not shorting, or maybe for telecommunication purposes you need it as close as possible, as accurately as possible. um, so that's another common unit used is mils. um, right here you can click right here and sometimes it can help you to line up stuff. Um, I don't really use it often, but if you click this right here, it'll expand the crosshairs to the entire screen. I'll close this now. Apparently this one, I guess sometimes some chips can have hidden pins. So this will hide the hidden pins or show the hidden pins for you. Um, not sure what this is. Switch H and V only move. Yeah, I'm not sure what that does, but it's just another thing you can toggle. By default, it's on. Yes. Hmm. We'll work with that a little bit more when we get to the layout because there's some common like millimeter distances like 0.254, 2.254 millimeters, 0.254 millimeters, 0.0254 millimeters, and those are varying amounts of mils. So that's like 1 mil, 10 mils, 100 mils. It makes things nicer than 2.54 millimeters. You can just say 10 mils. And then if you're ever wondering, you can just go to Google. If you type in mils to millimeters, you can type it in here. So one thousandth of an inch is 0.0254 millimeters. 10 mils is 0.254, 100 mils, 1,000 mils, million mils, so on. And it's just easier, I think, maybe than saying this in millimeters. You can just say 1 mil. Do you guys all have the circuit all wired up and everything? Still working? Okay, no worries. Are you looking for a specific component? Okay. Another thing I did forget to mention, maybe some of you figured it out, but while you have a component selected, you can click R to rotate it as well. Um, so that can help if you're trying to orient it specifically. You can also, if so I think maybe this component I might have had to do it. If it's not like the correct pins, the 1, 2, 3, you can flip the component by using these here. This is by the x-axis, this is by the y-axis. If I had it this way. It really doesn't matter, whichever side is connected. Sometimes when you have a really big component, like later on we'll be doing the developer kit, and it has a ton of input output pins. And sometimes you might not want to use every single one of the input output pins. So one of the things you can do is there's this no connect flag, and you can connect that to the pins so that KiCad knows, yeah, this shouldn't connect to anything. So it's a no connect. Another thing to keep in mind is for the wires, if you have the dot, that shows that the wire is actually connected. If you draw a wire across like this and you don't see the dot, then that means they're not connected. So you can overlap wires, it just kind of gets ugly to look at, is all. Another thing you can do is that if you have a bunch of like input output pins or some type of pins that are all connecting to a common common place, you can add these bus pins. I don't know, so like to all those. And so these should all be connected now. And then you can add, instead of a normal wire with W, you can add a bus wire. And so all these are connecting to a common point, all of these. And then this would go to some other component and connect to something else. That's something else that KiCad offers that you can do. If you make any other like mistakes, of course, you can Control Z all of it and undo everything you did. Another thing that's sometimes useful, if you don't want to physically wire everything, like component to component, another thing you can do is like, I can remove all of these wires here. And then you can make a label. Not that. You can make a net label. So you can make a label. I can name this label like power, right? For example, and then I can place this label here. And then everything else that I want to connect to this label, I can then duplicate it and connect it there. So all of these then, everywhere where you see the power label, these are all effectively connected with the wire like we had before. Sometimes that can be nicer if you have a really big design. It can get really messy trying to connect the wires to everything. So you can use these net labels instead. And then another thing, we'll see it later on when we get to the PCB layout. You can also name specific wires. So this wire will just be called 7. You'll understand what nets are a little bit later, probably next week when we go over it. But I can place a net here, call it discharge, and then it'll give that trace that name. So it makes it a little bit easier so you can see, okay, this is the discharge trace that I had. And it just means more to you as a designer to help you organize everything instead of like the number 7 from pin 7 on the 555 timer. You might not remember what that pin was. Now these labels, so these net labels I just made are only for this sheet. So if I had other sheets, so like I had mentioned a little bit earlier that sometimes your design is so grand that you can't fit all of it on this single page. So what you can do is you can go here and you can click add a hierarchy sheet here, and then you would give it some name. I'm going to call it test. And then I can actually copy this circuit, I'm going to cut it, and then I can put it in here in this hierarchy, and I can paste it here. And this can be like its own schematic. And then I can give this part hierarchical outputs. So like I can name this LED output, and I can put that here. And that's going, yeah, you have to put it as an output. It doesn't really matter. The shape is just for visual, so you see, okay, this is an output, this is an input. But now I can click on here to go back up, and this test hierarchy that I made, I can then add actually, I think import hierarchical sheet pen. There. So that LED hierarchy output that I made, I can put it anywhere on the box here, but I can then connect that to something else like this, just because I have this here at the moment. I can connect it to that pin. So that LED output from this circuit is then going to connect to this IO0 pin. So depending on how big your design is, you can create these hierarchies and then name those hierarchies. Um, uh, an important thing to keep in mind, last thing with like the nets here is all these powers are only connected within this hierarchy sheet. So if you have a power net anywhere outside of the sheet, it will not connect unless you're using this net label here. So this is a global net, and I typed global wrong. This is a global net. So anything this connects to will connect to anything, no matter what hierarchy sheet it's in. So it's important that you use the net label, global label, or the hierarchy label in a specific way. So that's all I wanted to go over with that. Then I'm gonna Control Z all that. We don't need the hierarchies or anything. I just wanted you guys to know that this is a extra feature that you guys are able to do. So just go ahead and save this. Go ahead, click on File, Save Current Sheet As, and then give it a name. I named it IEEE Badge. The file type, it used to be just SCH for schematic, but now with version 6, it's this KiCad SCH. So that's just the newer version 6.0. And go ahead and save it wherever you want personally. This is all I'm going to go over for today. Next week, we're going to talk about the footprints more and the layout and actually creating the PCB and making all the connections. So yeah, I don't know. Do any of you guys have any questions? You want to go ahead? What? This? Oh, it's a switch. Yeah. Mhm. Oh yeah. Okay. Um, I'm not sure. I think yeah. So like, it's kind of weird. It kind of like keeps the shape you made when you dragged it. You can like, you can grab the wire and then click move, and that will just move the wire. Compared to if you click the wire and try to drag it like this, it will extend the wire. So I guess maybe you'll have to move the wire around first, and then you can slide the component to like extend the wire like that. But if you just try and move the component with the connections, you'll get this weird, ugliness. I was wondering more with 45. Oh, okay. So like if you can create 45-degree wires, like while you're placing it, um, there is a way to do it, but I'm not entirely sure how. One of the things you could do is you can place a wire and then usually it searches for another connection, but you can double click to just have it terminate. Then you can click it and drag the corner. Oh no, that wouldn't work either. Let's see. I don't know if there's a specific button for it. You can, I'm pretty sure you can go to preferences here. And I bet you that you can go to maybe not. Huh. I thought maybe you could change how much it rotates by, but it doesn't look like it. Okay, in short, I guess I don't know. I don't know if you can create like angled wires like that. I'm sure there is a way. You'll have to YouTube it if you want to, but generally you want all the nice 90-degree wires because the angled wires kind of looks a little ugly digitally. Right, right.
I have like um, a lot of spaces.
Hmm. Yeah, that's where the hierarchy sheets kind of come in. You kind of want to keep the nice 90 degrees format. If you run out of space, then you might want to create a hierarchy sheet. And then you can put I gotta give them their name. Test. Okay. And then in this hierarchy sheet, you can move like whatever part of your design into the hierarchy. And then you can have the inputs and outputs from each circuit to the each hierarchy. Does that make sense?
I mean,
Oh, okay. So like with, with like the wires, like the traces, why would you want like we'll get there. We'll get there. Because like so this schematic has absolutely nothing to do with what the actual PCB will look like. Um, as far as like minimizing the size, there's nothing that'll automatically do it. You'll have to do it yourself physically and mess around with the traces. But once you actually place the traces, you can make the wrong connections on your PCB. You'll get a warning, and I'll show you guys all that, but it'll also show you with like lines based on the schematic that this pin 2 of this switch should connect to this pin of the resistor. And it'll show you like a general white line how you should connect on the PCB. We'll talk about all that next week, and you'll see. And I can show you guys how to create the outline for the board and stuff. It's really easy to change. So if you're resizing it, it's super easy to do. Okay. Um, Another thing, usually if you have a lot of extra space, you want to create like a pour of copper or a plane of copper. So that's when you have an entire side of the PCB just copper, or a huge block or section of PCB is copper. So usually it's best practice to take the extra space and just make it part of the ground connection, because it increases your signal integrity for your signal pins. We won't have to worry about any of that in this case, but if you ever get like really serious in the PCB design, that's something you'll have to consider. Does that kind of help? Is there any question? All right. All right, that concludes this workshop. So we'll meet again next time, next week on Wednesday, same time, same everything. I'm trying to get talk to Student Life about getting the events handled. Um, she has to talk to the professor that runs the supervises this space because I want to reserve this space just for PCB design. So this is where we will meet every time, same time, 1 to 3 p.m. And then if any of you aren't on mypnwlife.pnw.edu, or if you don't have the campus groups app yet, please check that out. That's where the events will show up and you'll be able to see the times for PCB design, for Python. We have a FE training section. So we're just going to practice doing FE fundamental of engineering exam problems to help students prepare for that when they graduate to pass their FE exams. We have that going on. I believe it's Tuesdays and Thursdays right now from 4 p.m. to 6 p.m. In the Potter 204 building. Evan Fuss is in charge of that. So he, email him if you have any questions about that for the FE training. But we have a bunch of stuff we're trying to set up for you guys. I'm trying to get an honors fraternity for all the IEEE members. It's called Eta Kappa Nu. So anybody with high honors or with a 3.5 GPA, you'll be able to join. And that's extra scholarship opportunities. I believe they have some scholarships that literally pay your whole tuition. So I'm trying to get that set up as an organization here for all the IEEE members too. I have to do all the documentation and everything though. I got the approval from the main uh outer group, the global group, but I have to create like a bunch of like rules and I have to assign a president and everything. So a lot. Um, what else? I think that's it. So I'll stop screen sharing. I'll save this recording and um I'll throw this on my PNW Life. If I just thought that maybe the recording might be too big to import. So if that's the case, then I'll set up a Google Drive and I'll throw it in there. And then I'll give you guys instructions on how to get to that Google Drive or like a link so that you can view that information. Okay? All right. I hope all you have a great day. Thank you for coming to this. You guys have any